Let's now divide our rational expressions. Again, rational expressions just means fractions, so probably not a bad idea just to review a division by fractions, which is numbers, so we can remember the gist of the process. What you do, right, is you leave the first one alone, so keep it, change to multiplication, and then flip the second one over. So dividing by 9/5 is the same thing as multiplying by 5/9. That's actually how division is defined, is by multiplying by the reciprocal. And then reduce like you normally would. So across the top, 1 times 5, and across the bottom, 8 times 3. You end up with 5/24. Nothing is different when you have variables. We're still going to switch to multiplying by the reciprocal. We're still going to then reduce a factor on the top with a factor on the bottom as much as we can. And then we're lastly going to restrict our variables to make sure we don't do any division by 0. Okay, so here we go. Leave the first one alone. Change to a multiply, and flip the second one upside down. Once you're here, do the same thing as you did last time in the previous part of the lesson. So let's see. Do I have another 7 to cancel with? No. I can cancel this m with this m. I can cancel this 6 with this 6. This m, though, that m's already gone. So this m's got to stay around. And then the m minus 7 with the m minus 7. What we're then left with on the top is just the m plus 3. And on the bottom, 7 times m. So there's our reduced expression. This divided by that is this, with a few notable exceptions. We got to make sure that the m value isn't equal to. Now, here's the thing. The division restrictions mean you have to check 3 places. I've got to check here and here, because those are very clearly parts of denominators. They're in the bottom of a fraction right now. But I also have to check here, because this used to be the denominator of a fraction. So when we're restricting this time, you've got to check 3 places. The 2 denominators once you flip, and then this one that used to be the denominator before you flipped. So don't forget to check all 3 of those when you are doing divisions. All right, so from here, 7 times m, well, the m was by itself, meaning no plus or minus on the end of it. So that means the restriction would be m cannot be 0. The same thing is true from this m. And from here, m cannot be the number 7. And then from here, m cannot be the number 7. So we're good. You don't need to list that more than once. So reduced expression together with restrictions, that's your overall answer. Okay, just some examples. I think I would like you to do a quick pause. Unpause when you're ready to check them. So I'm going to leave the first one alone. Change to multiply, and flip the second one upside down. Now, you'll notice I put parentheses around these. It just helps me remember that those have to stay together. Things that are added or subtracted inside of these fractions, they're married to one another. So what can I reduce? Is there another n plus 4? No. Is there an n plus 2? There is. Is there an n plus 5? There is. So what's left? On the top, just an 8. On the bottom, just an n plus 4. And now my restrictions. I need to make sure that n is equal to -4, -2, -5. And I'm also going to remember I have to check up here, because this used to be in a denominator. So that would be -2. I've already got a -2 listed, though, so we're okay. So the reduced expression, together with the restrictions, that's your overall answer. Next up, again, quick pause, unpause when you're ready to check things. So 10/2, switch to multiply, reciprocate, and now let's reduce. 2 and 10, that's just 5 and 1. 3 and 9, that's 1 and 3. There's no b's in the numerator to divide with. So across, 5 times 1 on the top, 1 times 3 times b squared on the bottom. And the only restriction is that b can't be 0, since if it were, we would be dividing by 0 and everybody would end up having a terrible day. Don't divide by 0. Doesn't work. That'd never work. Next up, I would like you again, quick pause, unpause when you're ready to check things. Leave the first one alone, change to multiply, flip the second one upside down. So the 2x plus 9 on the top, and then the 4, 2 minus 7x on the bottom. Let's reduce x plus 9 with x plus 9, bottom to top. This 4 and that 4 can reduce to 1. Be very careful here. Yes, I can do 7x minus 2 and 2 minus 7x, because they're both subtractions. The only difference is the order. But you got to remember, when you do that, you got to replace one of them with a negative 1. Always. If the order of subtraction is reversed, yes, you can reduce, but they reduce to negative 1, not 1. So what do we have then? On the top, just negative 1 times 2. And on the bottom, it's all just 1s. And so this reduces to the number negative 2. So this is a very fancy way of saying negative 2. With the restriction that you got to make sure the x value you use is not negative 9. From here, it would end up being what? 2/7. And then from here, negative 9 again, you don't need to list it more than once. So the reduced expression together with the restrictions, that's your overall result. And then lastly, now you may at this point be saying, hey, I'm pretty good at this. I can probably just do this in my head without actually writing down the flipped over version. I want you to fight that feeling, because you're going to start mixing together divisions and multiplications. It's going to get real messy real quick. Take the 30 seconds. Rewrite the problem the way it's supposed to be. So leave the first one the same, switch to a multiply, flip the second one upside down. It is worth it. It just makes it so much easier to make sure you don't make a mistake on accident. Top factor with bottom, top factor with bottom, top factor with bottom. We're left with reduced expression and now restrictions. So from here, n can't be 2. From here, n can't be negative 10. From here, n can't be negative 2. I'm out of space, so I'm going to come down a line. But remember, you've also got to check up here, because this used to be in the denominator. So we do have a final restriction that n cannot be 5 as well. So for your restrictions in a division, make sure you are checking original denominators and denominators after you flip the second one. That ends up meaning you're checking those 3 locations for your restrictions every time.